Okay, this is a question from a Year 12 Methods student. Evaluate each of the following using an area formula. So we are given these as integrals, but we're not going to use integration to find these areas. This is really useful for exams. Sometimes in an exam 1, you'll come across a function where you'll have to find the area under it, but using geometric means will be more straightforward than using rote learned integration techniques. So this is a good skill to be practicing. All right, let's get started. So for A, we want to sketch this graph. So we have our axes, we've got x minus 2. So that means we start at -2, 2, and the graph goes forever in both directions. We want the area from 2 to 5. Okay. So you'll notice straight away, hopefully, so this is our graph y equals x minus 2. And this point here has the coordinates 5, 2. So we have a triangle. We have a triangle with base 3 and height 3. The area of a triangle is half times base times height, which means the area underneath this curve is half times 3 times 3, which is 9 on 2, or 4.5 square units. All right, B. So B uses some information from 1, and you'll notice that this is the negative, the opposite of this guy. Okay, so what we're going to end up sketching is we're going to sketch the graph y equals the absolute value of x minus 2. And we're looking for the area underneath that graph from -1 to 5. So let's sketch. Give ourselves a bit more space for this one. So again, we're going to be here. That'll be our 2. And that's from this guy. And we're going to get the same graph coming along the other direction from this guy. Okay, so we went from -1 to 5. Now you'll hopefully be able to see pretty quickly that this has coordinates -1, 3. Let's look at our graph. 2 minus -1 is 3. And you'll remember from part A that this has coordinates 5, 3. Oops, but that was driving people a bit crazy. It should be a 3. So we don't need to do any more calculations after this. We have a graph with base 3, height 3, sorry, triangles, and we have another triangle over here with base 3, height 3. Not to scale. So this area we already know. It's the same as this area. Now I've got 2 right-angled triangles with the same height and the same base, so their areas must be the same. So the value for B, the area is 9 square units. Okay, C. So C is a little bit more involved. Let's just rewrite it. We have the integral from 1 to 2 of 2x plus 1 dx. So again, let's do a sketch. So let's sketch this guy up. Boom. plus 1, so our y-intercept is at 1. We've got a gradient of 2, so it's a bit steep. Let's just go back here, label our axes. Good methods kids label their axes. So this is the point 1, 0. So what's the value of this function when x is 1? 2 times 1 plus 1 is 3. So when x is 1, I have 1, 3. What's the value of this guy when x is 2? I have 2 times 2 plus 1 is 5. So 2 here, and I have 2, 5. And I'm looking for this area. So I've got a trapezium with top side 3, bottom side 5, and height as 1. So my area of a trapezium is 1/2 a plus b h. So this will be 1/2 3 plus 5 times 1, which is 1/2, times 8, which is 4 square units. Okay, so that's letting you use area formulas rather than integration when you're using a straight line. I do recommend practicing this. It often comes up in exam 1. Really useful skill to have, can save a lot of time. Good luck.